Hello guys, today I am back with the new tutorial and we are working on a tutorial series of LTSPICE. Before that, I would like to wish you all again a very happy and safe Diwali. Hope you all are with your parents and uh, still safe. And now it's time to be back yourself towards studies and focusing back to your work. So now, gradually I'm trying to increase the complexity level of the circuit. So here I brought you a new circuit, that is a peak detector circuit. First of all, you will understand how does this theoretically um, works, what is the operation and analysis of the peak detector circuit, that is a filtered half wave rectifier peak detector. So as you can see on the screen, this is the circuit we're going to implement on LTSPICE. So let's first understand what does this basically circuit does and what does this mean. So the circuit that is shown here is a peak detector circuit. So an AC voltage is as a source is applied to the peak detector. Then this charges the capacitor to its peak value of the input, means whatever input is highest value of the input is given, it charges the capacitor to that peak value. So the diode is in positive half cycle. If the diode is in positive half cycle, it's charging the capacitor to the waveform to the peak. When the input waveform falls below the DC peak stored on the capacitor, the diode is reverse biased and then blocking the current from the capacitor back to the source. Thus, the capacitor retains its peak value even as the waveform drops to zero. Okay, so it takes a few cycles for the capacitor to charge to the peak as it is shown in the figure. The waveforms are supposed to be as such. So after a complete cycle, it charges the capacitor to maximum value and then it doesn't drop and it retains its maximum value even in the reverse bias condition of the diode. And however, the silicon diode has a forward voltage drop of 0.7 voltage, which subtract the it from the wire voltage of peak value. So this is the cos where sine sorry cos where we're gonna give as an input source. And the circuit that is shown represents a DC power supply based on a half-wave rectifier. So the resistance are a few ohms, and due to the transformer's secondary winding replacing the voltage source and resistor. A larger filter capacitor can be used. Uh, Power supply based on some hertz source with a filter of a few hundred microfarad of supply would be given. So these are some values like um, for the resistor and capacitor that can be given over here. So let's quickly switch to the implementation part and let's see how does it work and how we can see the waveforms, whether we are getting this waveform or not. I am switching to the LTSPICE. So this is our platform of LTSPICE. Now first you need to take a new schematic. If you are not aware of what is LTSPICE, then you need to go back quickly to the first, second, third and fourth tutorial. That is the introductory part. That is the first tutorial to make you understand what is the LTSPICE, how to download it and what all are the components you can get. So click over here, you will get a new schematic and this panel is now active. Now we're gonna make our circuit. So I'll give you 2-3 minutes, like so that you can be a little bit ahead of me, and so that we can check the waveform simultaneously. So first of all, what is needed? Resistor is needed, diode is needed, capacitor is needed, right? And a power supply is needed. So let's take these components one by one. Voltage is needed. Okay. Place it over here, release it by clicking an escape button. then resistor directly you can take it from here as well and from the here as well. Okay, and to rotate it, control R. That's I keep saying in every tutorial. Release it by using escape. Take a diode, rotate it, control R, control R, control R. Okay, this is a normal diode, regular diode, not a Zener or other one. Place it, escape it, and then we need one capacitor. It makes a filter circuit. So now we need to do a connectivity. Ground we will add at the end. So take a wire and connect this components with each other as was shown in in the figure. You can take that snapshot for that figure so that you can easily just look at it and copy it over here and then release. Now one by one we will give the values to these components. Let's take it as a 1 kilo ohm. Okay, this resistor to be 10 kilo ohm. Okay, this has to be 1 microfarad. As I told you, it needs to be in some microfarads. Okay, then take a diode, such as in pick a new diode. IN91. Okay, this one I'm taking first one only. Okay, now we need to place a ground over here, otherwise your circuit will remain in a floating state and it will show an error. Escape it, go to this voltage source, the cursor changes its symbol to a hand, then right click, go to the advanced, and here we need to give a pulse or sign. We need to give a sign. Okay, so here the amplitude we are setting as a 5 and here as offset as a 0, this to be as 5, frequency to be like 60 hertz, delay we are not giving, theta we are not giving, phi I'm giving as a 90 so that it can be a cos function. Okay, and number of cycle, let's say 100 cycles. Okay, now we will do a transient analysis. Stop time maybe 0.2. So this is your input waveforms and that is the V in, and at the output, so this is the thing we are obtaining exactly the way it needed to be. So let's understand this graph properly, right? What is happening over here? See, you are giving a sine function, that is a cosine function because I shifted it by 90 degree of shift. So 90 minus theta, sine of 90 minus theta is cos theta. So like that I'm giving it over here. Then what is happening? First of all, it is in a forward bias. It is charging the capacitor to its peak value, and still due to the presence of the resistor, there are some noise and it cannot charges to the exactly 5, but it is nearby to the means above 4. You can measure it using a cursor as well, and then it retains its value and doesn't drop to 0, and this is how it works. So let's just check one more thing over here. I'm just changing the values of, okay, showing the current. What I'm doing, I'm changing the value of resistor from 10k to 2k. Okay, now run it, check at the input, and now I'm checking at the output. So now let tell me in the comment section that what it's happening over here. Tell me in the comment section what is happening over here. And Now I am showing you this by even increasing it to 20 kilo ohm, this value of resistor, and then run it. Check the input and check the out. So now please tell me what is happening. What is happening when you are reducing the value of resistor from 10 to 2 and from 10 to 20? So you need to comment in the comment section that what understanding you got from this. Okay, so you can see that here the charging values have increased. So what is happening behind the scene, you need to tell me that. And one more thing, to make this circuit professionally look more like in a circuit in a way, like you can give this naming, change this naming like VN, and you can give the name of this node, you can label it as V out. Okay, so it will look like more convincing circuit. You can run it. This is your input and this is your output. So now like you can see over here V out and okay, this is the name of the source, that is why it's the name is not changing. If you keep the name as V in, okay, okay, and run it, this is the V in and this is your V out. So now it looks more professional and more convincing that V is named as V in and V out as a V out the circuit waveforms. So hope this tutorial will be helpful for you, and using this peak detector circuit you will learn and understand and make its use in other circuits as well. So if you like the learning part, please do like, share with your friends, keep learning, keep practicing, and stay safe guys. Thank you so much.